Hi everyone, in this video we look at graphing exponential functions. So here it says exponential functions can be transformed in the same way as other functions. If we have an exponential function and it's written in the form f of x is equal to a times b to the power of k times x minus d, where k is factored out here, the graph of this function can be obtained by applying transformations using the mapping rule with a base function b to the power of x. Now, we looked at how to graph y is equal to b to the power of x in previous videos. We also looked at how the function differs if b is between 0 and 1 and if b is greater than 1. So using our base function, if we have the key points for y is equal to b to the power of x, a point on b to the power of x, that is x comma y, maps to x over k plus d, comma ay plus c on the graph of this function. So here we're just going to apply the mapping rule to transform this function into this function. So there's a couple things that are going to make our life a little bit easier when we graph exponential functions. And this is really just looking at the equation and saying to yourself, is there a way that I can make this this equation a little bit simpler? And an example of this would be, suppose you have y is equal to 9 to the power of x over 2. Well, I could graph the base function y is equal to 9 to the power of x, and then this would be a horizontal stretch by a factor of 2, since k is 2 here. Since since k is 1/2 here. Or I could just rewrite this this using the exponent laws. I could rewrite 9 to the power of x over 2 as 9 to the power of 1/2 to the power of x. And this is just equal to 3 to the power of x. Because 9 to the power of a half is just 3. Raising 9 to the power of 1/2 is the same thing as just taking the square root of 9. So I could rewrite this function as 3 to the power of x. In the next video, we'll look at an example where we actually apply the mapping rule.